The birth and wonders of the sun, an astronomical journey. In the vastness of cosmic space, a star shines with incomparable intensity, illuminating and heating our solar system. The Sun. We are Astrogeeks, your channel for astronomical curiosities and news. If you're passionate about astronomy or just curious about the history of the universe, you're in the right place. Don't forget to subscribe to the channel to follow fascinating videos and leave a like to strengthen our community. The appearance of the Sun is a spectacle of star formation. Stars are born in nebulae of gas and dust. And so it was with our Sun, around 4.6 billion years ago. From an interstellar cloud, gravitational collapse gave rise to a protoplanetary disk, which, over millions of years, concentrated matter in its center. This process led to nuclear ignition, giving life to our star. The radiant energy emitted by the Sun is the result of a process known as nuclear fusion, which takes place in its core. In this process, hydrogen atoms combine to form helium atoms, releasing an immense amount of energy in the form of light and heat. Nuclear fusion is possible due to the high temperatures and extreme pressures present in the solar core. The pressure is so intense that it forces the nuclei of the hydrogen atoms so close together that they overcome the electromagnetic repulsion between them, allowing nuclear reactions to take place. These reactions release energy in the form of radiation and subatomic particles, which pass through the Sun's inner layers until they reach its surface. The Sun's rays that we see on Earth are actually the direct result of this process. The conversion of hydrogen into helium releases a colossal amount of energy, which is emitted in the form of light and heat. The light generated by this process travels millions of kilometers, reaching Earth and warming our planet and sustaining life as we know it. The Sun is made up of several layers, each with different characteristics. In the core, nuclear fusion reactions take place, releasing energy. The radiative zone is the region where the energy generated in the core is transported by electromagnetic radiation, while in the convection zone, this energy is transported by currents of heated plasma that rise to the surface and then sink again. The photosphere is the visible layer of the Sun, from which most of the light is emitted. In it, we see sunspots, which are darker areas caused by fluctuations in the solar magnetic field. Above the photosphere, we have the chromosphere and corona, which are hotter and less dense regions of the Sun, visible during solar eclipses. Nuclear reactions in the solar core affect the different layers, generating heat, light and energy that propagate to the outer regions. The interaction between these layers is fundamental to the Sun's energy balance. Curiosities about the Sun leave us in awe of its grandeur. It is about 330,000 times more massive than the Earth and has a diameter approximately 109 times larger. Light from the Sun takes around 8 minutes and 20 seconds to travel to us, the speed of light being a crucial constant in our universe. Compared to other stars, the Sun is considered a medium-sized star. Solar gravity exerts a vital influence on the planets and celestial bodies of the solar system, keeping them in their elliptical orbits around the Sun. This phenomenon is what sustains our planetary system and determines the trajectories of the celestial bodies. Solar energy is the driving force behind climate processes on Earth and photosynthesis in plants. Without it, life as we know it would not be possible. The Sun plays a fundamental role for life on Earth. Solar energy is the primary source that drives our climate, influencing weather patterns, ocean currents, and much more. Plants capture this energy through photosynthesis, a process by which they convert sunlight into chemical energy, feeding the entire food chain. However, the Sun also displays its activity in the form of sunspots, flares and coronal mass ejections. These events can have significant impacts on our technology, from communication systems to power grids and electronic equipment, causing outages and damage. Therefore, Continuous research and monitoring of the Sun is vital to predict these events and develop mitigation measures to protect our technologies and infrastructures. Concluding our journey through the heart of the solar system, the Sun is not just a distant star, it is the basis of everything we know. Its energy, mystery, and beauty continue to inspire us and remind us of the vastness of the universe we inhabit. Thank you for joining us in this exploration of the Sun and the cosmos. Share your thoughts and what you thought of the video in the comments below, and don't forget to subscribe for more fascinating content about astronomy and the infinite universe that surrounds us. See you in the next video.